Intermolecular forces are the relatively weak forces between molecules that hold the molecules together in the solid and liquid phases. Intramolecular forces are the forces within a molecule, meaning the covalent bonds in a molecule that are much stronger than the intermolecular forces.
Oh!
I developed after I stopped smoking cigarettes. It's been helpful.
Ow. Do it without being
What are you
scared.
doing?
Yeah, perfect. Why?
How?
¿Cómo lo haces?
What? I mean, it's just bonding, guys.
How did you make the spaghetti?
Through intermolecular forces.
Dipole-dipole forces are the forces that act between polar molecules, or the electrostatic attraction between the positive end of one polar molecule and the negative end of another. You can see here water has positive hydrogen and negative oxygen, creating a dipole moment towards the oxygen. Whereas carbon dioxide, a non-polar molecule, does not exhibit these dipole-dipole forces. When these atoms are combined, you can see them grouping as such, positive towards negative, in this sort of array. A stronger dipole force would be hydrogen bonding, given here with water. Hydrogen bonding is given a separate name from dipole forces because hydrogen bonding is a particularly strong dipole force, whereas regular dipole-dipole forces are considered rather weak. Any neutral molecule that has hydrogen conveniently bonded to fluorine, oxygen, or nitrogen, or exhibits the relatively strong hydrogen bonding intermolecular forces. Other highly electronegative atoms can also be used. The reason these hydrogen bonds are stronger than regular dipole-dipole bonds are because of the high polarity involved in the bond and the closeness of the dipoles, because hydrogen is small. These stronger bonds also mean a higher boiling point, as the bonds require more energy to break. London dispersion forces are accidental induced dipole forces. They are electrostatic-like dipole forces, although the dipoles are not permanent, but accidental or induced. All covalent molecules, all polar and nonpolar molecules have London dispersion forces, but only polar molecules or those with permanent dipoles exhibit dipole forces. In other words, nonpolar molecules and noble gases do not have permanent, but rather accidental dipoles. This leads to weak intermolecular attraction. How is an accidental dipole produced? Well, the electron distribution of a molecule is not symmetrical at all times. And when it is asymmetrical, for a moment, a temporary dipole arrangement of charge is made. As the size of a molecule increases, the strength of the London dispersion forces increases as well. This is because as the electron cloud about a molecule gets larger, it is easier for the electron to be drawn away from the nucleus. to become asymmetrical in distribution. The molecule is said to be more polarizable. This directly relates to freezing points, as London dispersion forces, being weak, can only form a solid when atom movement greatly slows down. The bond order thus is as follows. London dispersion forces are weaker than dipole-dipole forces, are weaker than hydrogen bonding, are weaker than ionic or covalent bonding.